Hello, and welcome to this old blondie topper, or whatever this is called. Now, beam engines. You heard me, beam engines. We love a beam engine, don't we? But what are they? Beam engines were an early form of steam engine used in the Victorian era, and one of the first type of engines that were put into service. They are particularly magnificent when you look at the design. There's just a lot going on with them. Now, what we got going on in this long, overly extended and overly complicated build series is the construction of what's known as a model engineer's beam engine. Now, this was first designed, this particular one, around 1914. And it's gone through a number of iterations, and this particular design was revised around 1959. I bought a set of castings for this one from Reeves in the UK, and it comes with a revised set of drawings. This kind of kit is available in various places around the world, a lot of very similar configurations. And basically, I felt like going with a set of castings because they add a level of ornateness and interest that you don't always get with a bar stock engine. And it just adds a layer of challenge because it just adds another layer of work holding and setup that just takes some thought. And so it's just a challenging thing. There's a number of engines of this design on YouTube running that are really interesting to watch, but I haven't found a build log for one anywhere, and I haven't found a build log for this particular engine on a forum either. Usually what happens when I make this kind of announcement on YouTube is immediately 300 very good detailed video series appear, so maybe that will happen this time. But anyway, what we're going to do today is have a look at the castings as they arrived, general overview, and we'll make a start on the base casting. So, thank you for watching. If you haven't subscribed already, please do so. You know it makes sense and it helps the channel grow. Please click the like button there. Just give it a click there, not the dislike button. If you want to click the dislike button, do that twice just to make sure people know you really dislike it. But please follow along. I hope you'll find this enjoyable. I'm going to take the approach of trying to take a geometric approach to the machine, in which I try and understand what the relationships between all the different parts are and machine everything accordingly, and not just trying to kind of match drill things to other things. Nothing wrong with that. I'm just trying to up my machining game, so I'm just taking a slightly more detailed and frankly long-winded approach to it. It's just what I like to do. So let's have a look at the castings. Here we are over at the bench. Just take a look at the castings as supplied, just to give you an idea of the quality. They are reasonable. There are a few voids in them. Don't know how that's going to play out as we machine these, but we'll see. Certainly some of them have some flash. I think the patterns for these are quite old. You know, this engine design has been around for a good long time. But flash and other things aside, I'm not really concerned about that. Yeah, this one might be the roughest casting of all, honestly, and it's not that bad. I wouldn't say they are as good as the PMR4 castings in terms of quality, but they are more ornate. Take a look at the beam. I've seen comments about the beams not being straight and about the bosses being offset side to side, but from what I can tell, they're actually pretty well matched up. There's the central column. I don't know if you can hear that, but there's a semi that is a lorry that's been Jake braking up and down the road outside all day. Sure he's having fun. That's a hefty piece right there. That looks good. Looks like the patterns are nicely matched up. You know, bit of flash, but overall I'm very happy, and you can see the nature of some of these parts. It's just going to look very pretty, I think. I think it's just going to make for a very nice display piece. And this is the bed plate. Originally, these used to be made in cast iron, but apparently they're making the bed plates in aluminized aluminium. There you go. How's that? Aluminium aluminate for the true international traveler. Away we go. First thing is to take a look at the casting and establish just what it is. So I'm going to start by using feeler gauges to go around the underside and just see how twisted the casting is, and then touching off on the top of it and on various features using the height gauge, just writing down height measurements on this one surface just to get a feel for how straight it is and how warped it is and how much stock I have to play with when machining these features. Now that we understand a little bit about this casting, we're in a position to get it set up and ready to actually take a cut. So what I'm going to do is use the central square here as the main reference surface, because I've got to choose something. And I'm going to support it in the same way that I measured it, because I discovered that by supporting it chiefly here, I can minimize the rock and I keep everything more or less in the right plane. So first thing I want to do is deck off the underside to give myself a good flat surface to clamp down on when machining all the top features. So pretty simple. I'm going to clamp through this center hole. I'll clamp through this hole to get a hold of this end. This end, a little more tricky. I will either clamp it and then move the clamp, or I may chance leaving it unclamped but just supported. Since I'm going to be taking the bare minimum of material at any time, like 1/10 thou at the most, until I get a cleaned up surface all around, I think that will be okay. So here we go. I will just check our relative positions. These 3 points are matching up, so that's, I'm going to call that good enough. Okay. Just taking very light skim cuts here, 10th thou at a time, until I get complete cleanup around the entire flange. Well, where are we at? Got the casting set up on the mill now, and I've got it on top of this sacrificial aluminium plate, which I skimmed flat on both sides previously. I actually did that for the PM Research #1 engine. I also took a straight edge to various features on this casting and was pleased to find that these sides and the sides of the top square boss here are quite straight and quite perpendicular. Checked all that previously, so that allows me to do what I've done here, which is to square up the casting by touching off on actual features. And the way I did that, I don't like dragging a test indicator across cast surfaces. I don't know if it would actually damage the indicator, but it might, because, you know, it shakes the living daylights out of it. The needle goes all over the place just from the roughness. So it can't be good for them. Certainly doesn't help you get it set up straight. So all I do, just quickly show you how I do it, is bring the part in on the Y and just zero the dial. Go to the DRO, then back off. And when you're first setting it up, I just go a long way down. Bring the casting back out. Zero on the indicator again. And then I can have a look at the reading on the DRO and see where I am. And I've managed to get this so that it's straight on each side within about 10, and the same along these axes, which for a casting that's, you know, not at all flat in real terms, that's pretty good. So we've got a total variation of about 20 thou, straightness, parallelism and everything else. So that should set me up very well to machine all of these features, put all the whole features in, and have everything look good on the cast item, and then be true to everything else. So what I'm going to do is establish, let's get off of this. Rather than go the way the drawing shows, which basically shows each set of holes as their own pattern, and then the center of each of those set of patterns relative to the center of this, I'm just establishing the center of this square in both directions as the 0 point, and then everything's going to come off of that. And I've made a new drawing with those dimensions on to make it easy to refer to, and I did that by longhand first. I put some white out on a copy of the page and then started longhand figuring out what all the dimensions were. And this is like my second go at it. And it just ended up getting so cluttered that I couldn't read in my own writing. So I just quickly modeled it in SolidWorks and made a drawing that was just a little easier to read. Now, using that with the DRO just is going to make it very easy to get everything positioned accurately. and that will maintain geometry of the center of the cylinder to the center of the beam, and then the center of the beam to the center of the crankshaft, and therefore the center of the flywheel, that's the important geometry. And then having all the bearings and various other features all accurately positioned and straight relative to all the different axes, that's what we're shooting for. Now, traditionally, what you could do is paint a gallon of blue all over this, like, you know, model engineers like to do, and then start scribing features, and you'd be able to make an engine that works. But by doing it this way, we'll just be that much more accurate that we have a chance of everything fitting together and running right off the bat without having to do any bedding in. That's kind of what I'm shooting for. So now the one other thing I'll talk about is there are two features that are nominally bolted straight to the cast surfaces of this plate. What I'm going to do is a minimum cleanup in those two areas to make sure those areas are flat as well, and, you know, parallel to the other machine surfaces, which will mean I'll need to adjust the height dimensions on those two items to account for that. But you know, we're talking about a 10 or 15 or maybe 20 thou cleanup, so not a big deal. So with that, next thing to do is establish center lines on this, and I'm going to set up a test indicator to sweep that. I was having a lot of difficulty sweeping with a test indicator, so I ended up just going to my trusty edge finder, which worked out great on the rough edges of this casting. So as you can see, looking at the X, I'm getting about 2 to 3 thou run on that surface, and I'm getting the same across here and across here, so it's pretty straight. I wanted to use a test indicator to sweep these surfaces, but I just wasn't getting it right, and I was getting frustrated, and I think this is going to do perfectly fine. So this is where we're at. Okay, so we've got our center line established. I say ours, it's mine. You're just watching and probably yelling out derisory comments, which is entirely appropriate. I've got a nice 3/4 inch end mill in here, insert end mill, which has aluminium/aluminum cutting inserts in it and does a very nice job. And furthermore, I've been around with a height gauge and touched off on the surface of the casting that's to remain unmachined, and established that that's got about 20 thou wave in it, which is I was expecting, and which frankly is fine. Not going to get that out by shimming it, it's just in there. And the only way I'd get it better is by dusting off the top, which there's no need to do. But then I've also gone and touched off on all of these surfaces and established, using a cheat sheet, that we've got roughly 50 to 60 thou to take off. So, for instance, on the square, we're looking at a final nominal dimension above the cast surface of 09375, and it's currently measuring between 141 and 145 thou tall, and then similarly for the others. So I know that I have plenty of stock to take off all of these surfaces. So what I can do is start with the square, which is the reference feature for everything, and I can get that to the correct height. And then I'll come back and machine all the other surfaces relative to that one. I'll make that 0, and then come down the appropriate amount to get those where they need to be. So they won't be made relative to the cast surface here, they'll be made relative to that, but that's the one that's important. That's what holds the beam, that's what positions the beam, so everything has to be made relative to that. So there. Now unfortunately I am going to have to extend the quill for this. I prefer not to do that, but this part is short enough that it's using up all the travel on my knee, which if I was a good machinist I would have thought about and had this up on 246 blocks so that I wouldn't have to extend the quill. But I'm going to be taking such light cuts anyway that that's not really going to be an issue. So what I'm going to do, because there's no DRO on the quill or on the knee axis on this machine yet, I'm going to bring down the mill, touch off on this surface and then lock the quill, and then all height adjustments will be done by the dial on the knee, which is very accurate, and I know that because I've tested it. Let's go. That'll do. I'll bring the knee up for the rest of it. Yeah, just scratch the surface, that's all I need. That's my 0. Set the hand wheel, and I'm just going to do a 10 thou now. I know that I'm looking to take about 50 off. Now that went just fine. So I'm going to take another, I'm going to take 20 off now, so a total of 30. Now I'm going to go around and do a sweep, just because this is an unsupported casting, so there might be a little bit of spring. I mean unsupported right under this feature. Ah, good. Good, can't feel any ridge there. So we'll do a height check. That's now at 125 in that one spot. Another 35 to come off. So what we'll do, we'll put a spot there, just so that we know that's not important. I just want to check what the mill's doing as we go. 105. So yeah, 20 thou off. So the dial is doing what it's supposed to do. This dial. Huzzah! So another 10. And then the plinth is done. Now that's great. I can't feel, although you can see them, which is perfectly normal, I can't feel any of those changes in direction at all. So this is trammed nicely. Okay, so this is the highest spot on the casting. That's why I machined it first. So now I can drop down to the next highest and then the next highest, and I'm never dealing with backlash, or the backlash is taken out. I'm only going one direction. So next surface is this one where the cylinder mounts. This one has to be 32nd lower than this, so that's 03125 nominally, lower than this surface. And then both of these and these are both a 1/16 of an inch lower than that. This one requires actually machining material away from these edges as well. So that's why we needed this center established, because I've got to come over here to the center and then come out in both directions to clean that out, as well as clean up the surface of that. Anyway, this one first. So what I'll do is clean this one up, then I'll drop down, do these, and then I'll move over and do these. Earlier I'd stated that I was going to machine the center square and then just continue dropping, actually raising the knee to get to the other features, but that's not in reality what I had to do. Of course I had to keep lowering the knee down to get back to the starting surface of each feature and not just take all of the material off in one go. So I did have to allow for backlash, which is no problem. You just go way past 0 and then come back to make sure backlash is taken up. And it's good to understand the feel of the backlash on the mill anyway. Right, change the vantage point a bit so you can see a bit more of what's going on at the knee. So we just got done with these two bearing supports, and now I'm going to drop the knee down so that the mill clears everything else and get it over to these two features. Now come way past 0 and back up to take out the backlash. I'm going to stop above 0. And then, just for safety's sake, I'm going to come way off the part to move over. Now the center of that feature is 4.5938, and this is where I am going to use the DRO. That should put the milling cutter right in the center of that feature. Certainly looks like it. Now we're probably at a point where I will cut the surface, so I'm actually going to just drop the knee down a little bit more. There, so I'm about 40 thou above that surface. Now, how I'm going to go about this is I'm going to take enough off of that to get back to the 0 point, which is coplanar with that. Once I've done that, I'm going to move out, take a light cut at each end, and then measure the width, and then figure out how much more I have to take out. I know I've only got to take out a small amount, like 20 thou each end, so I'm just going to literally dust those clean first to get a measurement, and then and what I'll do is I'll use the DRO to understand how much I'm taking off each side. I haven't explained that very well, but it is what it is. I got to concentrate on actually making the part, so I'm not going to say any more. I'm just going to film it, and if I need more explanation, I'll do a voiceover. So now that plane is level with this. So now we're going for the 1/16 of an inch in 20 thou increments. Now I'm going to leave 12.5 thou to take off when I get the width established. So now, knowing the diameter of the cutter and where the center line is, I've got my numbers, so I can clean up the sides of those features there. This is supposed to be 2 inches wide, and I'm actually going to shoot to make it 2.01 because there's a bearing that has to go in there, or maybe I'll shoot to make this a nominal 2, and then I'll just make the width of the bearing a close fit because that will just help keep it aligned. Yeah, I'll do that. The width as cast right now is 1.908. It says 1.905. Depends where on the casting you take, about 1.9. So about 50 thou a side, assuming that's even, to come off. Which means roughly there should barely touch the surface. So let's find out. I'm still at this height. And I'm just taking out the bottom corner now. Lovely. So that's all going according to plan. Now I'll go up the other end. Lovely, there we are, just lightly skimmed. Now I know I'm not going to be taking monstrous cuts. So I'll just go out. I'll write my numbers down. Take a quick measurement. Let that stop. Take a quick measurement using my knot scribers. I have 64 to go. Does that jive with my measurements? Yeah. .999. Suppose that could be spring as well. So I'm going to leave it there because now I'm going to drop down to final height of this, and I can take out, I bet this just the spring pass will take out that final 1 thou. I might just nudge it over each way a touch. But anyway, now to final height. If I really wanted to get accurate on the final height without a DRO, I could put a test indicator on the table to monitor fractions of a thou, but these heights within couple, I think, are going to be plenty good. Yeah, we'll take that. So that's the start of what I intend to be a very painstaking build of this Model Engineer beam engine. You can see the level of precision that I'm going for. It's an attempt to replicate good machining practices based on understanding geometry, rather than just marking out and transfer drilling and things like that. Nothing wrong with those techniques. I'm just trying to up my skill level a bit, and that's the reason for this exercise, and my personal satisfaction. It's not some kind of one-upmanship bullshit, just the way I happen to want to do it. So please don't read anything more into it than that. Now I'm out of time. In this video, I wanted to also show putting the various holes and patterns in, but I'm out of time, and I've got stuff happening in the next couple of weeks that's just going to prevent me getting any machining on this done very much. So rather than wait for the entire thing, and given that this was an introduction anyway, I'm going to leave it there and publish what I have, and hopefully this is a good intro and gives you an idea as to where I'm going with this. So with that, thank you very much for watching. Thank you to all my new subscribers and also all my existing subscribers. If you're new to the channel, please likey and subscribey, because it just helps get it out in front of the Googleified algorithm, and hopefully in front of people who may enjoy the content. So that would be appreciated, but your following along is very much appreciated. Lots more things in the works to come up. not just the engine, but some fixturing and tooling stuff, and some excellent feedback I've had from viewers and subscribers. Indeed, on my lathe cross-slide lock, a few people have tried that, and I've had one really excellent suggestion back for an alternative approach in the same thing, which I'm going to design and make, and I want to show you that as well. So lots to come. In the meantime, if you'd like a channel sticker, whether you have a channel or not, doesn't matter, shoot me an email here, and I will gladly send you one, free of charge. And besides that, we've got Thanksgiving coming up in America, which is a very important holiday all about seeing family, and I'm going to go and see some of my family. So with that, may your dimensions always be in tolerance and your surface finishes chatter-free. Be seeing you.